So we'll do that. Yeah, we can, at that point, yes.
We can talk about the next cohort, the current cohort.
All right, everyone, welcome. How's everyone doing? Welcome to the meetup tonight. We got a full house. I know there's 200 more people who wish they could be here, but they couldn't get in. But thank you for coming tonight. We have a great program. Before we get started, I want to thank SprinkleBit for hosting us here tonight. It's always a challenge finding a great venue that's free to us, so we don't have to pay to come. So thanks to SprinkleBit. I want to let Alexander come up and introduce himself.
Hey guys, so I'm Alexander Wallen. I've been running SprinkleBit for the last 6 years, and I've been interested in cryptocurrencies for the last 4 actually. When Michael asked me for a space, I figured this would be a good space for us to have it. And just a quick little plug about what is SprinkleBit, except for being a really cute name. What do we actually do? So SprinkleBit, we teach people how to invest, and we see that the future investing is not only about investing in stocks, bonds, and those boring things. We see that a part of your portfolio should also be in cryptocurrencies. That's why this is a really good interest for us right now. So that's pretty much about SprinkleBit. And if you guys think that it could be exciting, download the app. It's as simple as Facebook. You got your friends on there, you got me there. If you got any questions, if you're asking if Ethereum is going to go up or down or what's going on, I'm going to be on there to answer some of your questions. So thanks. That's pretty much it.
All right, so there is one seat here, and maybe one if we clear that seat on the couch, and one over here for you guys if you prefer to come sit. So we got a great presentation tonight from the Grid Plus team. I will let them introduce themselves. We got Mark D'Agostino, Igor Lilic. We'll let them kind of give their background and talk about Grid Plus decentralizing energy, which I think is one of the huge disruption opportunities that exists out there. So thanks.
Hey everyone. So we're gonna talk. What's up? Oh, poll first. Okay. Yeah. So who here is like new to this space? Like knows about blockchain? Say what, 3 months or less, roughly. Okay, a handful.
What about 1 year or less?
Okay, cool. It's roughly half. Okay, fun. So we're gonna talk about Grid Plus, which we'll get into the background and everything else. But really quick plug. I actually don't think it's the most important project at Consensus. Consensus is awesome, and we'll kind of go into that. But I actually think Wheeler, wherever he just went to, yeah, it's too bad for him. But I actually think Infura is probably one of the fundamentally most important projects in the Ethereum ecosystem. So you should definitely talk to Michael afterwards. So Consensus, who here has heard of Consensus? That's like most people. Okay. As of last week, and it changes every week, which is absurd. I think we have about 312 people now. When I started working with Consensus, we had about 12, I think. And that was actually through Igor and his brother, John. A couple of years ago, I was working at Deloitte, and I was actually down the block over here at 100 Wall Street. Spent 3 years on Lehman's bankruptcy. Got pretty into Bitcoin like early 2012. And then this whole thing about Ethereum came about. I met Igor's brother, John, at a meetup down at the Bitcoin Center. Eventually, I sold a project to build a loyalty platform on top of Ethereum, and Igor and John introduced me to Joe, and we hired them to actually build everything out. So most of the early code that actually was sitting on Microsoft Azure for blockchain as a service was all written by this guy. So the single-click deployments, like spin up your own private Ethereum instantiations, were pretty much all by Igor, which is super cool. But where we are now is a totally different space. So for Consensus, we kind of have 3 prongs. One is deep infrastructure. So we wrote something called Truffle by Tim Coulter. It's got 120,000 downloads or so. We have Infura, which I mentioned as, again, I think the most important project in our space. They are processing 800 million to 1 billion requests per day, which is absurd. And to give some kind of context, I think Michael mentioned before that it took Google 5 or 6 years to hit 1 billion search requests in a day. So Infura is doing that now pretty much every day on the network. We also wrote 2 of the Ethereum clients. That's the Haskell client and the Java implementation. There's like 8 or 9, I think. Another Another, I guess, vertical of our company would be product, which is where Grid Plus sits. So we're kind of set up as a BetaWorks type venture production studio. So we have 25 or so different companies that are eventually, hopefully, going to spin out as their own separate standalone entity, but still like maintain and be part of the consensus mesh. We'll talk about what that means. And the third one is Enterprise, which is the group that Igor and I actually started, along with 3 others. And Tyler is part of that group, amongst others who are here, including Brent, so you can go say hi to them afterwards if you're curious. We do a lot of consulting for Fortune 500, some governments, and a handful of central banks around the world.
Mark forgot to plug one project, which is MetaMask.
Yeah.
If you guys are Chrome users, go and download MetaMask. You'll have an Ethereum wallet in your browser. And some super, super cool features coming soon with MetaMask, but I won't spoil it for them.
Right on. So the Grid Plus core team was kind of founded by Alex Miller, Carl, and myself. So Alex is our lead Ethereum developer. We were working on energy projects together for about a year at Consensus, and these are for large, like Fortune 50 energy companies. He was the lead developer on all of those. Carl is a PhD in material sciences. He was studying large format lithium-ion batteries. He had built his own consortium in Texas to go do this. So he's pretty much just like an absolute hardware and battery nerd, and he's fantastic. And he's been designing most of our like agent system we've been producing over and over. And then we have, luckily, Matt's here. I don't know if you want to introduce yourself, say hi.
Sure, yeah. So I come from sort of like a Node.js background. I've done all sorts of applications development over the years, but I got involved in Node.js in sort of early Node 0.4.7. Built a couple startups on it, built everything from a corporate bond exchange to a high-tech touchscreen treadmill. And it just so happens that, well, the future of decentralized apps has a lot of JavaScript. And so pairing Node.js with decentralized single-page JavaScript apps is a pretty good thing to do. So I'm coming on board to help build a lot of our services.
And decentralized hardware.
There we go.
And not with us today, we have Claudia, who is based in Romania. She's a researcher doing a lot of really advanced stuff, looking at lightning networks and liquidity for off-chain scalability. We can talk about what that means afterwards, but really there's a bunch of different ways that Ethereum is going to scale up rather than just all on-chain transactions, and one of which is something called Raiden, which we're doing a big analysis on, like how do you properly fund hubs to create efficient pathways for funds to flow without having to like go to chain too often. And then Yun is currently burning the man, so she's not around, but she is based in New York. She's our design lead, and Pablo's our intern, helping on marketing. He's based in UT Dallas. Bunch of advisors who can't be here today except for Igor.
You need an eye on Pat's last name.
I saw that, but it was cut off the picture. What are you gonna do? So, do you want to talk a little background?
Cool, yeah. I think Mark alluded to it a little bit. So Consensus is almost 3 years old, which is super fast. We started in October of 2014, and we've been working in this Ethereum space since then. Even before Ethereum was actually out, we've been doing Ethereum ecosystem development. And Grid Plus traces its provenance back. Actually, a couple of projects that we did, energy projects with partners and clients. Starting way back in 2015, we worked on the Transactive Grid project, which was a joint venture between Consensus and a company called LO3 Energy. We actually built microgrids, plugged them into the Ethereum blockchain, and that project was actually here in New York, in Brooklyn. So from that, we kind of collected our learnings, iterated, and engaged a company called Inergy, which was at the time RWE, yeah, which was the second largest utility in Germany. So we worked with their teams to do a proof of concept called Cotricity. We did a lot of kind of consumer engagement, working with residential solar and actually plugging it into your local grocery store and kind of selling your electricity to the grocery store when their peak demand was high and you were out to work. So that was a really interesting proof of concept. And then the third, large client builds. We have, again, with Consensus Enterprise, we are doing consulting work all over the world. Some of these companies are in the energy space and really want to understand how blockchain technology can apply to the future of energy, to the future of smart grids. You would recognize the names, but unfortunately we can't talk about them right now. But all of those projects through the years kind of collected our learnings and the Grid Plus project is a result of 2+ years of learnings in the energy space, working with companies from around the world, massive companies, small companies, just to understand the landscape and also understand the capabilities of the Ethereum platform, and also how the roadmap for the Ethereum platform is going to influence our energy projects and Grid Plus specifically as it evolves.
So one of those large client builds, we actually built 2 different decentralized exchanges, one with a continuous kind of auction, another with batch processing. And we actually put all that code onto smart batteries. So we repurposed their private keys because they natively don't do ECDSA signatures, so they can't make Ethereum transactions. So we took their private key for a different curve and repurposed it for ECDSA, which we wouldn't actually do like in practice because then the manufacturer has everyone's like capabilities to like move things on their behalf. But that was a proof of concept. There's about 8 networked homes in a country in Europe who are doing this now, but that's looking to move to phase 2 later this year. The goal is to get between 800 and 2,000 homes connected to energy trading for prosumers, which is pretty cool. So what's it mean to be a spoke within Consensus? So like we said, with this venture production studio, what we are in the process of doing now is building up our team and eventually going to spin off. So we will stay in the Consensus family. We're all hanging out in Slack together. We have the ability to go talk to really, really smart people. Like we were talking about embedding Uport into our agent device so we can ping Dr. Christian Lundquist at any time to learn about the cryptography behind it, which is super cool. So I don't think we'll be leaving Consensus, but it's kind of like moving out into our own separate standalone legal entity. Our focus is really on one product, which we'll talk about, which is this hardware agent. And we plan to do a token launch later this year. So the electrical grid. Who here is like actually like an energy person and knows the energy ecosystem? 3. Cool. Okay.
You guys can't ask any questions.
Yeah, don't ping. I'm not the energy expert like Carl probably is, although we've done a lot of work in the energy space. So for the most part, in the United States, the electrical grid's pretty good. And this is kind of what it's made up of. You've got generation, which are these large 1 megawatt producers. In our case, we're looking at the Texas market. So you have these massive plants in like West Texas, and they'll then transmit all this energy over these high voltage lines for hundreds of miles to get to distributors who like step it down to low voltage, connect it to homes, then the last mile is the retailers. Basically, all the retailers really do is they pay for wholesale energy in these kind of like a decentralized market where they can participate in, and then they bill their customers. They typically mark up costs by about 100%, which we think is really high, and they're super inefficient, so that's what we're going after. So I know a lot of people talk about microgrids, and we built a microgrid in Brooklyn before, and microgrids really are great for certain situations, like what's going on right now in Texas. Like it would be really good, like with Hurricane Sandy, like having microgrids is a great fail-safe. But the electrical grid in the United States is pretty robust. We think it's going to continue to be robust, and we plan to continue to use that rather than trying to build out a series of microgrids. Currently, there are problems with the grid, though. And if we look at renewables, we know that solar keeps picking up, and that's fantastic. But it's intermittent kind of generation, and it does actually cause problems with the grid that could be alleviated in certain situations, like if people were actually storing the solar and then putting it back into the grid when like the actual infrastructure needs it. But there's no incentive for them to do so. Most retailers don't use something called time of use pricing. Time of use pricing, kind of as it sounds, like depending on what time of day is, the price of energy is going to fluctuate. But typically the solar producers, when they sell back to the grid, they get this kind of flat rate throughout the day. So there's no incentive for them to store it and then sell it back at a more efficient time. So if we look at these 2 graphs, solar penetration's kind of been on this upward curve. That's great. This chart on the right is known as the duck curve, I believe, where you see that solar gets produced during the day, and before that happens and afterwards, the grid has to like move up for all the load that's on the network, and it's actually really difficult for them to do so. And in certain situations when solar is too high, you get something called curtailment, where they basically have to destroy energy because the infrastructure itself will like blow up otherwise. If we had an incentivized system wherein people had a benefit to store and then pump back energy back into the grid where it made sense, like this could be flattened out and infrastructure would be way more efficient. So looking at retailers and why we're going after that market, we've worked with a bunch of large energy companies. We're still working with some on the enterprise side. We know that the retailers and utilities, for the most part, they're quite inefficient. Not all of them, there's some forward-thinking ones, but on the whole, many of them are pretty inefficient. They're not really selling any kind of differentiated product. You might be stopped in the street by someone from Green Mountain Energy or whatever saying that you can buy, clean energy, but really you're still buying the same kind of dirty energy, but they're giving like this renewable energy credit to offset it. That's producing like some wind farm in Kansas, but that's besides the point. So it's inexpensive, and these gimmicks sign people up. Either give you like a Nest thermostat, or we'll give you a decrease in pricing for a certain amount of time. But really, at the end of the day, it's like just marketing schemes they spend money on, and marketing is expensive in this space. Like it's going to cost us a good amount of money to acquire customers as well. They do something called risk pooling. So basically, everyone has to pay more than like what an actual upstanding citizen would be paying. So if you pay all your bills on time, you're actually subsidizing the cost of people who don't pay on time. Because at the end of the day, like these retailers are credit facilities. Like you use energy throughout the month, and then you true up at the end, you pay them. But not everyone does that. Then there's certain regulations that require them to continue to service you and give you energy for a certain amount of time thereafter. And all of those like costs are not going to be like incurred by the utility. What they do is they pass on to everyone else in their system. So for the people who are like, paying on time, it's actually not the best situation. And on the administrative side, they're just pretty inefficient, still using really old technology, and we want to change that. So where are we going to attack? Two different types of markets for energy. There's regulated and deregulated markets. You could think of a regulated market as kind of like a vertically integrated monopoly, so that generation, transmission, distribution, and retail is all the same entity. We're not going to break into that market. The only way that we're going to break into that is if we license our technology to them, because we can't come in as like and beat an incumbent who's doing all four of those things, because we're not going to be a generator anytime soon, and we're not going to lay our own lines. So deregulated markets are a bit different. The way a deregulated market works, it's almost kind of like imagine a democratized market where anyone can choose to participate. So you have generators putting out like prices and bids into this market where people can then choose to buy and sell what's being produced, and like anyone can participate so long as you're a registered utility there. So instead of having this one entity who kind of is this dictator as to what's going to happen, you have a market-based system, and that's where we're going to play. Texas is our location of choice for a bunch of reasons. One, it's fully deregulated. Two, they have high solar penetration. Three, the energy is relatively inexpensive already. And probably four is that Carl went to, got his PhD from UT Austin, and he knows that market really well. He's built a consortium there before. So then about Grid Plus, what are we trying to do? We want to operate as an efficient electricity retailer. We want to enable smarter consumption, meaning that consumers, by doing certain things, will be able to have their agent purchase energy on their behalf in a more intelligent way than they currently do now. Eventually, we'd like to get to the point of peer-to-peer energy networking. That is not on the roadmap for day one at all. And then finally, and we had a conversation about this before a little bit, but stable coins. We want to end up issuing a stable coin on the network, and ideally using some kind of off-chain scaling mechanism like Raiden in order for that stable coin to kind of perpetuate and be used as the standard currency. So how are we going to do this? We talked a bit about retailers in Texas. So really what we're going to do to leverage the public Ethereum network, we're using something called payment channels or state channels. Who here has heard of state channels? Okay, a couple. Good. I assume most of you haven't. It's kind of a simple concept. So we learned really early on that you don't want most of the logic on chain. So if you put too much logic on chain, one, it gets expensive because every single mathematical operation that Ethereum has to process, you're paying gas for. So you want to as minimal kind of attack vector as well on chain, and ideally you want everything kind of done off chain in a provable way so that if someone tried to fraudulently do something to you, you can kind of pass their proof back to the chain so that you're made whole. So the way we do these things called payment channels or state channels, basically if Igor and I locked up funds, like let's say Igor's a bartender, I go to the bar, we open up a channel, like if I swipe my credit card, that initiates a channel every single time where he's passing me a new drink or whatever, we're kind of just updating the state of how much I owe him, and we close down at the end. It's the same kind of logic here. We lock up funds on chain between us and our customer. As they're consuming electricity, we're pulling out these Bolt tokens. They're paying in real time every 15 minutes. None of those transactions have to hit the chain, and we just close out once every month or two to update balances. So really 2 transactions, a couple of cents of the network rather than massive amounts of fees. All of this is open source, by the way. If you look at Alex Miller's GitHub, it's all kind of out there. I think most of what you're working on is all open source too for this. Yeah.
You can follow Ethereum Alex on Twitter.
Yeah, Ethereum Alex, he's fantastic. So one of the things we do is we want to remove any kind of bad debt expense that we can incur. So we're not going to operate as a credit facility. We require upfront payment from our customers, and that's what gets tokenized. So there's no fractional reserve of any kind. Like, we don't believe in that. We don't want that. We don't want to incur the ability of having to like go chase people for their money. So essentially, they have to pay upfront, and they will have energy costs deducted as they use energy throughout the month. If it gets to the point where they're not like properly funding their account to a certain level, they'll get notices of it's like, if you'll have a shut off kind of like in energy, you'll get like 2 or 3 weeks, whatever is required by the government. But that's kind of how we operate to minimize any kind of bad debt expense. One of the cool things about this is that what happens, because they're buying energy in real time, they get exposed to wholesale markets. So typically, most retailers will take that wholesale price and they're going to mark it up like 100% to pass to the retailers. What we're really doing in this agent device is kind of acting as a pass-through, so that the wholesale market passes through directly to our agent. So they buy in real time at nearly wholesale pricing. And the whole point of our like token is to essentially allow people to buy directly at wholesale prices with zero markup on our end. Okay. So the smart agent. I think Carl can talk about this for hours, and I'll try not to go too deep. It does get pretty technical, but basically we want an always online device sitting in your home. This is a rendering, but we've built 3 of these so far. We've been 3D printing them. There's gonna be a large demonstration with Toyota Research Institute in September down in Austin. I think it's in Dallas, where we're working together on a couple different pieces here, which should be interesting. But basically what this device does is it sits in your home and it's able to, in real time, make payments on your behalf. What that means is, well, I guess the reason why we need something like this is because IoT generally is super insecure. Like, you wouldn't want a smart meter in your house trying to make these payments. You wouldn't want like a Nest thermostat trying to make these payments. You need something like, think of like a Ledger Nano S, where you have a secure enclave. We need a general compute environment. We need a secure compute environment. We need this to be able to sign transactions on this ECDSA signature and blast them out to the entire network in a way that no one can attack it, no one can break it. We also want to prevent like physical theft. If someone breaks in your home, that they can't steal your funds also. So we have a pretty complicated like architecture for how the system works, but that's kind of the reason behind this. We want an in-home device that's able to make these payments in real time directly to us. And that's like use case number 1 for this agent. So this is kind of a very simplistic view of what it might look like. You have your general compute, secure compute environment. We are having this manufactured like specifically for us. There's really nothing on the market that can do what we want to do now, including the chips. So a lot of the secure enclaves out there actually for the SECP 256 R1 curve, which is not what we use for Ethereum or Bitcoin. We use the K1 curve. So yeah, Carl's having a field day kind of playing with this, but we will bring on some hardware experts to ensure that we get this right. Probably won't be able to produce these in any kind of like mass form until Q2 or Q3 of next year is my guess. The goal of this is that even if someone breaks into your home, it will be impervious to physical attack. And that's with something that we actually recently filed a patent for, with a 203 blind key multi-sig setup, which I guess we'll talk about maybe in a minute. But other uses for this wonderful agent, and Michael Wheeler, hopefully he's smiling back there because Infura is on the screen. So if you have this device in your home that actually makes signatures on your behalf in a secure way, what can you do with it? Well, if we throw in an SD card, maybe it can be an IPFS node. If you throw in some memory, maybe we can put Infura on there. And in your home, by just decentralizing the Ethereum network, you might earn some Infura coin. If there is an Infura coin one day, we'll see.
There is no Infura coin as of right now.
As of now, we'll see what happens. What I thought was really cool is the idea of securing the network, like once we move to proof of stake with Casper. So real quick, proof of work, everyone know what that is? Roughly, cool. Proof of stake, do you guys all know that switch? Okay, cool. So in proof of stake, essentially you're gonna bond yourself to the network. You are gonna be required to make votes. You actually have to like do these prepares and commits. If you are not voting, if you go offline, if you fail to make signature, if you're getting DDoS, doesn't really matter for what reason, you'll start earning a negative interest rate. I think it's at like negative 8% per year until you go back online. As long as you're preparing and committing on time, you'll start to earn this, positive interest rate. One of the problems that I have, at least like with how some people are thinking about actually staking in the system, is where are you going to store your private keys? How are you actually going to make these signed transactions? Are you going to keep your computer on 24/7 and go to work? What happens if there's a power outage, or what happens if something breaks on it? It's not the best situation. So what we wanted to do is basically run maybe in Azure, maybe Amazon S3 bucket, have it run in Casper code, have it pass these raw unsigned transactions to our device do a check to ensure that they both comply with each other. And if they do, in our secure enclave, we'll make the signature and then blast out to the network. So that way we have a way to secure the network in an always online device that's using a secure enclave similar to like Ledger Nano S, but it's able to be online all the time. So it's like plug it in, type all the stuff.
You also need to add the identity use case on here.
Yeah, I know.
With the UPort plugin.
You could talk about it quickly if you want.
Well, it's just this idea of hardware devices, also having identity and also having reputation, right? So your node on the network, is it a good peer? Is it behaving properly? Is it sharing properly? That actual hardware device can gain reputational attestations through the UPort platform. And so, one of the things we envision, even, speaking with Mike about this from time to time, is, a future where the devices that are on these networks are able to actually identify one another and learn things, discover things about that device via the network. So I think that's a pretty cool use case that we're only beginning to explore in the blockchain space, but certainly folks like OneName and 21Co also really are focusing on identity. So stay tuned on that one.
Yeah, and we have had quite a few conversations with Dr. Christian Lundquist and Reuben Heck and talking about what would UPort look like on this device. They have a really cool social recovery mechanism where, like, if you lose your phone or whatever, you don't have access to your identity anymore, you can specify, say, 5 people who you trust, and if 3 of them make a signature, you can recreate a new private key that owns all those attestations that sit in the smart contract. So we have something somewhat similar. It's not really social recovery, but we do want recovery mechanisms for this, and that's kind of where we get into, I think, this one's a little more complicated, but kind of high-level architecture for how the system works. Most of this stuff is relatively normal for a smart meter talking to the grid. Our pieces kind of up top there. MS1, MS2, and MS3 are multi-sigs. This is optional, but we think it's really important. Basically, we want to create this 2 or 3 blind multi-sig key structure wherein you actually don't know what the private key is on your agent device. You get no backup. There's no 24-word seed or anything. There's no sock draw attack, which Carl talks about often, which I think is here, because this is one of the problems in crypto. It's like you secure all your funds on this Ledger Nano S, and you're super excited, it's great. Then you write down these 24 words and you hide in your sock drawer. And what's actually going to happen in the real world? Someone breaks into your house. It's like they find a ledger, and it's like, oh no, I'm foiled. No, I'm just going to go find your backup, and you're screwed. So we're actually building a system wherein you don't ever need the private key on your agent device. And it's using a 2 or 3 multi-sig between the agent device, your mobile phone, and us. So if for some reason something terrible will happen, it's going to take some identity verification and whatnot. It might take a day or 2, but we will then be able to reconstruct and recreate that on your behalf.
So this one is really cool. I just want to point it out. So because this is a multi-sig setup, the blind multi-sig part, this device has a secure enclave, which is a secure compute environment, which has your private key. But you can never access that. You don't know what it is. There is a PIN pad on top of the device, so you'll have to enter your PIN to unencrypt the key such that the device can sign the transaction. But you don't ever actually have access to that private key in and of itself, and that's what makes it blind. You never know what it is. So that's pretty cool.
Yeah, and with the typing on that keypad, we can structure it so that in the computer environment, we can whitelist which addresses you might want to be able to send to, maybe your other addresses or family members or friends, so that if someone did come in, they actually can't move any of your funds off into some address that they control because they have no access to that private key. So, peer-to-peer energy network, probably don't need to spend a ton of time on this, but transmission's expensive. If we're able to incentivize, and we could build a system where we have time of use pricing and we're able to incentivize battery storage so that people are going to charge their battery during the day when solar is super cheap, and as prices rise later in the day, they can start giving energy back into the grid, and they're getting rewarded for doing that, for offering this kind of ancillary service to the grid. We get to save a lot of money on transmission costs instead of sending it hundreds of miles from West Texas into the end user's home. So longer term, this we shift away from consumers going into prosumers, which was what John Lilic was talking about constantly with this Brooklyn microgrid that we were super excited about in the early days. But in the early days, we didn't have things like Infura, MetaMask, Truffle. It was super hard to program everything on the network. It was a great POC, but I don't think that was going to move forward.
Well, I think it's interesting. This concept of peer-to-peer energy networks might sound kind of sci-fi and futuristic, Well, A, I tell people all the time we actually live in the future right now, so remember that. But two, with stuff coming online, like our friends at Energy, I don't know if you've read about their efforts in the news, but they're actually enabling charging stations. In Germany, I think they have a POC in the States as well.
Yeah. I think it's in San Francisco.
They're plugging charging stations into the Ethereum network, right? So there are aspects of the grid that is becoming plugged into Ethereum, so it is happening right now as we speak. So what the future of the grid looks like with blockchain enablement, I think we're trying to discover that and learn, but science fiction is today, 2017. It's really cool.
The last piece, which I'm kind of excited about, the way I think that this could play out for whoever does this really well is to basically become like the PayPal of Web3. So one of the problems on the network right now is that you don't have access to a fungible token of value that maintains parity with a currency that we all use every day. Maybe you might believe in Ethereum and everything else, but I would not want to enter into a Gnosis prediction market for who's going to win the Super Bowl next year and have Ether as the underlying, because Ether might fluctuate 5,000% one way or the other, and even though I might win my bet, like the price went down so much, like I lost. It's really silly. A bunch of teams are working on decentralized ways of doing this. You've got the Maker team, they're doing really cool stuff. You've got, I don't know if they're called variable or stable, variable right now, they're doing really cool stuff. We think that longer term, that's likely a fantastic solution. One of the problems with both of those, I think you need a lot of participants kind of going long and short on derivative bets of Ether to have this kind of like output of a stable token, and then for people to constantly re-up as it's going to maturity on those bets. And I don't think we have enough people on the network right now who are willing to kind of do that. In the future, it's very likely that you can build a decentralized stablecoin, but until then, we're hoping to basically create that for the network. And what we're doing for that is something called Bolt. Every time a customer pays us money as a deposit to purchase energy in the future with their agent, we tokenize that into Bolt. They get Bolt onto their agent device. Every 15 minutes, they're paying us Bolt for the energy that they use. That Bolt basically can sit into off-chain scaling solutions like a Raiden hub. So we talked about those state channels before. What Raiden does is, rather than just connecting two individuals to state channels, you can almost imagine like you pre-fund this hub in the Raiden network, and then individuals can connect to this hub, and that people will want to jump through to make transactions. Like maybe if Tyler and I don't have a connection with each other, but we're both have a connection to Igor and he has this large hub, we can basically, I can send transactions through Igor all off chain in a provable way that have really, really minimal costs, that if at any time like Tyler wants his like money out, he can pass a proof to the chain and he can be funded. So like this is an off-chain scaling mechanism. Heiko Hess and his team at BrainBot have been doing really awesome work for a long time, and we're super excited to start like playing around with it.
So I have another poll question based on what Mark said. Who knows how many transactions have occurred on the Ethereum mainnet to date? Does anyone have any guess?
I'd say Wheeler's going to come closest.
You can't. So we 650,000. It's actually, and I'm cheating because I have it on Etherscan. It's 52 million. 52 million transactions have occurred on Ethereum since July 31st of 2015. So we are seeing more and more transactions pick up on this network. If you are into Ethereum, use dApps, make transactions. Let's get the network going even more, right? Growth is good, and growth pushes innovation and change, and the sooner we have bottlenecks, the sooner things like Lightning Network or Raiden will come out. So use Ethereum. It's really cool and it's really fun.
Yeah, and the easiest way to get up and running is, I'd say, MetaMask, which you plugged before.
Yes. MetaMask is.
But Raiden, so Raiden's for Ethereum. There are other off-chain scaling solutions for say Bitcoin. So we talked about Lightning Network quickly. It's starting to finally happen after like years of waiting. So Peter Willey wrote something called Segregated Witness, and SegWit basically takes some transaction signatures out of like where the block is actually stored and stores them in a separate place. And what it really did was fix a transaction malleability problem in Bitcoin. Because of a quadratic hashing problem function, like what happened was miners were able to change the transaction hash IDs afterwards, so you couldn't really lock up funds on chain because you wouldn't be able to trust other people for like keeping that identifier of locked up funds. But now with SegWit and the Bitcoin fork, that's finally going to happen. We're going to start getting Lightning Network transactions, which is super cool. One of the problems with Lightning Network though is like
there's no UI.
There's no UI, yeah, that's one problem. Another problem is kind of what our researcher is working on right now in Romania, Claudia. How do you fund hubs efficiently? Having one monolith of a really big hub that's really well funded isn't actually a great solution because that means everyone has to connect directly to that, and you're actually not saving a whole ton. So like we're actually looking at how do we optimize funding various hubs in locales for which individuals transact with each other often. So it's an optimization problem we've been researching quite a bit. We have a pretty robust paper that we'll release in, I guess, the coming weeks or so, but we think it's absolutely necessary for our system in order to do it in a really optimal way. So we have this affiliate program. It's not really for anyone here, but we have a lot of enterprise clients we've been working with a whole bunch in the energy space. We have others reaching out to us, consulting firms and stuff that we work with. So we basically set up an affiliate program just for 1 year so we can distribute our research to them and kind of like collaborate. There's a few of these going on in the energy space, but this is just something for us to kind of give back to the community. I'm assuming most of this will be like open source. We'll be sharing with everyone else as well. So I actually don't want to really talk about the grid token too much. I think Michael Wheeler's done a fantastic job at these meetups to get people talking about the technicals of what they're building and not really to pitch anything in particular. So I will skip this. You guys can chat with me afterwards. Really long story short, a grid token is your way to access wholesale priced energy. It's that simple.
Read the white paper.
Yeah, the white paper's good. It's long. It's like 65 pages or so, but it's pretty thorough. We talk a lot about the energy markets. If you're just curious the crypto stuff, you can skip towards the end. That's it. We're happy to take questions from anyone here.
How do you guys compare yourself to use Power Ledger?
So in January of this year, Alex Miller and I were in Amsterdam at a utility week conference. It was at the Rockstart Accelerator. Diego of NL and like a few other utilities invited us there to go present. They did not share how their technology works at the time, so I wasn't sure if they're using Ethereum or something else. Like, I think as of now, it looks like they're using a private blockchain of sorts, but they want to do fundraising on the public chain. I'd like to see some more technical details before I kind of give an answer. I have feelings on private blockchains. Feel free to go to blog.gridplus.io and read my post about no country for private blockchains, why I think they're pretty much useless. Unless you peg them to a public chain, you can read about like Vitalik and Plasma and all that. So it gets a bit complicated, but I think a private chain on its own isn't fundamentally all that important. It's always gonna be less efficient than a database. To run a consensus algorithm on top of, your database will be slower, and if it's just your company doing it, what's the point? But that's just my perspective.
But I
Digress. Good question, though.
I noticed, what happened to New York State? You said just like cut us out and take a picture and went right to Texas. I mean, what happened?
I love New York. I've been living here for.
Can you repeat the question for this?
What happened to New York State? Why are you going directly to Texas? There are a couple of deregulated markets, right? Texas seems to be ideal for a bunch of reasons. One, it's completely deregulated. Two, there's a very large ISO market. Three, there's solar penetration already. And four, we know the market really well. So both Carl and Alex got Carl got his PhD from UT Austin. Alex got his master's in mathematics from UT Austin. Carl ran a consortium in Texas of like 9 large energy companies that were doing testing on large format lithium-ion batteries. We know Texas really well. We've participated there. To run a utility, you need people who are like experts in the space, who have a certain amount of years anyway, to like actually get approval for. And so we know people, we know the space. My guess is Texas will be first. If we prove that this works, we will move elsewhere.
The short answer to New York is also Con Ed, right? They are one of these kind of fully integrated organizations, especially in New York. I mean, your power bill probably comes from Con Ed, so it's a bit of a monopoly here.
What are some of the lessons learned from the Brooklyn experiment and L3 Energy? Just stay on the topic of New York.
Yeah, I actually remember answering that when I was on a panel at the Consensus conference. There were a bunch of lessons learned. One of the first ones is like don't do too much on chain. That's one. Two, we had infrastructure at the time was like really weak in Ethereum. Like we started building out that system before there was a public Ethereum blockchain. We started in March or April of 2015. And this whole thing didn't launch until July. So it was like really early days. Those are two problems. I don't know if you have another one.
When you were talking about it, I think one of the interesting things, again, going to regulated, deregulated markets, One of the projects we were working on was in a regulated market where the devices themselves are regulated. And so you as a vendor can't actually have access under the regulation to the smart meter. You have to go through what is known as a consumer access device. So it's this like secondary device that plugs into your meter. And one of the things we were asking our client was like, wait a minute, can't we just integrate these two into a single device and have the transaction signing and the smart meter all in one piece of technology? And that was actually regulated that you couldn't do that, right? So you can't have a device that's enabled by, I mean, you could, but you have to go through all these regulations and bureaucracy to get approved, and it's usually only given to one vendor and these kinds of fun things that sometimes come with regulation. And so that's another reason that we are looking towards deregulated markets, so that you can bring new technology innovations to the marketplace.
If you fast forward, when we started working on those large client builds where we built decentralized exchanges to allow prosumers to trade energy back and forth to each other, we purchased a handful of smart batteries to do this. The problem was we actually couldn't do this like at large scale unless we had full approval from that company. It was really nice. Their CTO was fantastic. We worked with him. We had engineers in their team, but it's put all of this logic on a smart device. We couldn't legally do that on our own without sign off from them. There's a lot of black box kind of devices out there. So yeah, it's the structure of both of those or multiple previous engagements were inhibited by regulatory problems, by inability to access certain things that we needed access to in order to feel safe and secure about it. It's what I say all the time. Here, Igor, what kind of environment do we work in?
Byzantine environment.
Byzantine environment. You can't trust anyone. Don't trust anyone with your keys. I wouldn't be comfortable selling something to customers if a third party was building out these kinds of systems and had access to all the private keys. And I don't think that's a path forward. So that's another thing we learned there.
In regards to these deregulated energy markets, so Texas, for example, why have centralized smart grid companies not penetrated the market? Why has no centralized company integrated some sort of dynamic energy pricing solution?
Well, time of use pricing is actually happening.
Okay.
It's just slowly starting to happen.
So
it's not there yet.
So what's the plan to? So in terms of actually getting adoption, what's the plan to beat out all these centralized companies?
Well, one of the things Mark says all the time is if the centralized companies start to outcompete Grid Plus, that's a win in his book, right? It's about improving the infrastructure of the grid.
Yeah. We had a relatively large utility in Europe basically tell us if you're successful, either regulations are going to change to make you guys fail, or other utilities are going to do exactly what you're doing. They have a bigger war chest and they'll be better. My response was, if they're going to copy our model and offer a better service to customers, cool, that's fine. We can die out.
And another way to respond to the question is to say that a win in this case is a reduced for profit margins. So why would they do that without someone else being in there?
Well, it's just the innovator's dilemma.
Exactly.
Yeah.
So that's where we stand in this market, and that's why it's an opportunity.
So the crypto OGs, and Joseph Lubin is one of them, will tell you this is all about disintermediation, right? That's what all this blockchain stuff is for. And if you can price intermediation, if you can bring down the cost to what is actually the cost, not the rent seeking plus the cost, then that's a win. That's a win for this ecosystem. And I think when you're looking at projects, when you're investigating potential, projects to follow, I think one of the things to look for is where is the disintermediation happening? Because I think that's an interesting, compelling part to these blockchain projects.
And Joe likes to often cite, I think it was Coase's theory of the corporation, right? So when the marginal cost of a transaction is less expensive to outsource it than to do internally, your corporation's too big. So really, a lot of these companies, all they're really doing is playing that intermediate role, and they're extracting some rent to pass wholesale markets and with a markup to their end users. We think that's silly, and there's a better way.
Can you talk a little bit about what it's like for the Grid Plus consumer? How much they have to buy the device?
Yeah, it's a great question.
Money, presumably. How much do you think they'll save?
They're gonna have to buy the device. It's actually, the parts are not all that expensive. It kind of depends if you can produce in scale. Real quick question: who here bought a Ledger Nano S?
Or a Trezor.
Or a Trezor? Sure. Well, funny thing about the Trezor, Carl's been hacking one for the past like 2 weeks, and he's going to put up a video where he's playing Pong on it to show you that it's really not as secure as you all think, but I don't want to scare you all.
They fixed that patch. If anyone from Trezor's...
Yeah, sorry, we still like you guys. So, sorry, the question was...
What is it like?
What is it like to buy? Yeah. So we think this will cost somewhere in the $35 to $50 range, which is less expensive than other hardware devices and offers substantially more security. And we can get into that, of how that actually works. Most times when a new utility penetrates a market, you spend a lot of marketing, like customer acquisition's expensive. We imagine that we're probably going to give away a bunch of these to early customers. We also imagine that we're going to give away these grid tokens that, when redeemed, give you wholesale access to that energy, so no markup from us at all. If a customer has to understand crypto in order to use this, we fail miserably. I don't want any of that to happen. Basically, we have a mobile device kind of mock-up. Like your app will be able to say, click a button to redeem. It'll tell your agent device to make a transaction. You don't actually know anything's happening on Ethereum. That's the goal.
And those I can answer a little bit more as well. We're building a React Native app, so you'll have a mobile app, and then it will connect to your agent. And you can see all your past payments. You can go ahead and pre-buy some grid, which is renewable for kilowatt hours, etc. So it's easy to use mobile app.
Those hardware prices are not set in stone.
No, I mean, sure. It depends how many you produce also. If we're doing a run of like 50,000, it's going to be substantially cheaper than producing 300. I mean, right now we're 3D printing these and we're hacking them together. So.
What about cost, like monthly bill?
Yeah, so we imagine that for people who aren't redeeming grid tokens, that it'll be roughly 30% above our wholesale costs rather than the 100%. So still our goal is to operate more efficiently.
So you've mentioned regulators possibly passing laws trying to turn the tides against you guys. Do you guys face any active resistance against these legacy infrastructure companies who just don't want you to succeed?
I actually think it's been more friendly than that. Like, we've worked with some of the world's largest energy companies, and we've worked with them for a long time. I think most of them actually see that this whole blockchain thing is happening. Like, I've been doing this talking to enterprises since Ethereum just had launched, and before that. We've talked to multiple central banks and presented the PBOC in China, talked to the Russian central bank, we've talked to some of the world's largest governments, we've talked to, I'd say 80% of the Fortune 500. Like, I don't feel like many are trying to attack us and hoping that we fail. They're actively all playing around with this, trying to figure out a way we can succeed.
I think one of the interesting things about energy utilities that we have talked to that come from these more regulated environments is, in their regulated environment, they are a natural monopoly, and they can't compete outside of those kind of boundaries, right? So they're like, we're good in our little sandbox, servicing a country of 50 million or whatever the numbers may be, and so they're eager to see where innovation can come from, because they kind of have, in their jurisdictions, they kind of have that head start anyways. Like, they could start implementing behind and still catch up in that marketplace. So the cool thing about blockchain and Byzantine environments is innovation is outsourced, right? So all these projects that we're seeing, Grid Plus one of them, it's bringing new models and it's testing them, right? And so these, it's cheap for someone to stay in the sideline and just watch how it unfolds. Hopefully they bought Ether when they started on the sideline, but in any case,
Yeah, and I'm actually flying out to Shanghai tomorrow night to go meet with some potential partners there. And then I have a trip to Tokyo, talking to large utility there. We've been in conversations with a few who already are reaching out to us wanting to license our device, even though it's not built and ready to go yet. So they are excited. I'd say in the coming weeks, you'll probably see some kind of large announcements for the people we're working with.
I'm interested in some of the alternative uses you talked about for the secure enclave, signing transactions, continuously running nodes. Is the idea that once you've unlocked it, it will continue to sign transactions on your behalf that have been
So transactions to us based on what the readings from the smart meter, yes. Other transactions where you're trying to send large sums of money, you can have it set up so that it only goes to whitelist, so someone else can't break in and enforce some kind of bad transaction. If you're going to do something like staking in Casper, you're probably going to pre-configure that, test what can be signed, what are you going to prepare, what are you going to commit. If you're going to build something like Infura, the whole point would be to automate it. So Ethereum is totally decentralized, right? And then everyone realized, okay, it's really hard to do a bunch of things. We need more infrastructure in the space. Enter Michael Wheeler and team. They built this really kick-ass product called Infura. And now, I don't want to say it's a centralized service on Ethereum, but it's handling 1 billion requests per month. It's like massive cloud cost that everyone's pointing their dApp, or per day.
Per day.
Everyone's pointing their dApps to, right? So it's like, what if Infura itself was decentralized on all these hardware devices all around the world?
Yeah, and I mean, you know, Consensus in when we were babies in October of 2013, we started as a software company. As we grow and evolve, we go more towards the hardware space. And so, you know, it's interesting. You know, we are an Ethereum company. This is an Ethereum project. There's a lot of other cool blockchain projects out there. We kind of tend to focus and go deep. And so, you know, bringing Ethereum to hardware and firmware, and kind of as these new innovations unlock in the Ethereum public chain, to be able to bring that to the firmware of these devices and bring that in a friendly customer experience, you know, is something we're really interested in.
Yeah. And to be fair, we have some Bitcoin lovers on our team too. I'm one of them. So we'll probably end up supporting that as well for your agent device.
So one quick follow-up on the kind of automated signing of transactions. Can you authenticate the data that comes from, say, a smart meter, or has that become a point of weakness or attack in the system?
So that data goes into the ISO market already, these smart meters, right? I guess one could hack them. I don't really have enough information there to really talk about.
So there are edge cases that we're going to discover as we grow and go to market. But again, you know, these markets do exist. So we're going to leverage as much of the infrastructure that already exists and kind of add this other device.
Yeah. One other follow-up to the smart meter. Like, there's pretty much 100% penetration of smart meters in Texas right now. It's ubiquitous. It's everywhere.
Mike, how much time do we have for questions? Because I guess we have high demand.
We can probably go till 8. They would like us to kind of be out in the room back to normal by 8, and I have to be the last one to leave. So
Okay.
So maybe
we'll be quicker.
3 more,
10 minutes of questions.
Sure.
3 or 4 more
Fire away.
questions.
Yeah, if you could just comment on ERC20 and
Sure.
how you see that playing forward with other people using.
Great question. ERC20 is fantastic. Simon de la Riviere and others built out a really great thing that allows for interoperability of like tokens to be able to move. So like atomic swaps of tokens. That's kind of what we're talking about here. By having all these tokens have a standard kind of functionality set, it allows us to do really cool things. So our grid token is an ERC20. Our Bolt token is an ERC20. If you talk to Alex Miller, he has certain kind of improvements that he wants to make on the ERC20. I think EIP 186 might be one of them. You can go check that out. We want to build provable burn functions rather than sending it to like a 0x000 account, like to actually fairly remove them from supply. So I actually think ERC20 will get upgraded over time, but for now, it's awesome.
And shout out to Hudson Jameson and the whole EIP process. Yeah. More standards. Standards are a good thing. Tokens are a standard. It was Mark mentioned Simon. It was a huge collaboration between a ton of people in the ecosystem to get that standard, and it has added tremendous value to this ecosystem. So standards are a good thing, and Hudson's awesome.
Agreed.
What kind of impact do you see Grid Plus having on the environment compared to the existing grid?
It's kind of hard to tell, but if we build a more efficient grid with less energy being burned, less energy needs to be transmitted over long distances, it'll be less energy wasted. So hopefully a beneficial one.
How do they exactly do the grid tokens give you access to the wholesale? How do you pull that with that?
We can catch up after, but really all it is you redeem it to us, and your next X kilowatt hours that you purchase will be at wholesale price with no markup. It's that simple.
Yeah, so for the rated network, is that already in production, or is that still under development?
I think I checked yesterday and they're at 86% on GitHub.
I think there was a tweet from someone on the rated
It was
team.
Left Terrace today.
Yeah. So they're getting there. We're all eager for it.
Yeah.
What about sales tax in electricity? How do you plan to collect that?
What was that?
Sales tax.
Oh, I mean, we know every bit of electricity that's being spent. The smart meter device, we have access to that, so it's really not a challenge. One thing I didn't really touch on briefly, that brought me to mind. So your agent ideally gets smarter over time with the more data and information you expose to it. So one of the things we want to do is be able to pass encrypted data to it, have it use the private key to decrypt that data. So like if your phone has a calendar on there and you're traveling away for a certain amount of time, like your home doesn't need to heat up or use AC or something like that. So the more data we're going to expose to this agent, the smarter it can get over time. So a lot of what we're doing right now is how do you optimize for where you're going to be, how far away from home at any given time, and like weather patterns. We had a pretty good call with another startup yesterday talking about how they are able to do better predictive analysis on how much your home is going to consume based upon what materials your home's built out of, and then like what weather's coming in, what kind of fronts, is it going to be rainy, how hot is it going to be. So ideally in the future, your agent device is processing all of that and making smart purchases on your behalf, because buying in the day ahead markets is substantially cheaper than buying in real time. Or most of the time it's cheaper.
The machines are getting smarter.
Is that something that the consumer can control? So there is a debate whether for larger centralized utilities to be able to set the price of your central air, whether you're in or not.
Yeah, so yes, and like dispatchable loads like your Nest thermostats and things like that, we can do that like already. Like you're not gonna be forced to give your agent any kind of information. If you want to, you can choose to like opt into something like that.
What is integration with something like a Tesla Powerwall?
Great question. We're big fans of Elon. Go to our website and you'll see the Musk era on part of our roadmap. We have integrated certain things with smart batteries before. We have not done that with the Tesla Powerwall, like by ourselves. What's up?
Roof tiles? Does it matter?
It's super cool. They expose an API. We can integrate with it.
Is that basically the smart meter that you're integrating with and manages the whole thing?
No, so the smart meter I don't think is the central hub there. I think Igor mentioned before these CAD devices, consumer access devices, might be that in some regions. They're not always required, but something like a Tesla Powerwall and Nest thermostat, they expose their own API, so we'll actually be able to have our agent talking directly to them.
And open source those libraries, maybe? Maybe not.
We open source a lot of stuff, all of our payment channels and things like that. I don't think the actual hardware on all this and the secure enclaves and stuff will be open source, but I mean, we'll see.
Hi. So you said you sell this time of use.
Mm-hmm.
Is that like if I want to use it now, then you sell it to me now?
Oh, time of use pricing just means that at a given point in time, there is a cost of electricity, right? So like if I'm buying in the wholesale market right now, it might be 6 cents a kilowatt hour, but 15 minutes later, it might be 6.2 cents. We pass whatever the current price is if you're buying in the real-time markets directly to the end consumer. We're not going to all of a sudden make it 12 cents an hour and then 14 cents and then try to like even it out throughout the day.
So you can sell futures, right?
No, that's not really futures. You're participating in day-ahead markets. You have to take delivery. I don't know how it gets categorized in the energy markets, but you can either buy in real time or in like a day ahead, or I don't know how far in advance they go in Texas.
Texas is completely deregulated, right?
Correct.
So you wouldn't really have, say, like an agency that's concerned about consumers protecting supply types. So for example, like right now, a lot of the power grid in Texas is out.
Yep.
But grid like this would allow for you to have electricity. So you would have something like.
So I mean, if the grid's down, like we're kind of screwed here if we're not using a smart grid, right? If we're not laying our own pipes, our own like.
Okay, I was just thinking of the Brooklyn, the one that.
The microgrid, yeah.
The microgrid. I'm sorry.
Yeah, no worries.
So again, microgrids are super cool, right? And if we had a microgrid in Brooklyn during Sandy, we could have deployed it and had kind of local generation. Again, laying the pipes, laying the infrastructure, it's a huge capital cost. We really think that microgrids will proliferate in the future because they are a useful addition to the grid, but they are not necessarily what we at Grid Plus are targeting.
My guess is they will proliferate in areas that does not have the same like robust infrastructure that we have in the United States.
So how does this kind of integrate into my electric bill? Like when I'll see the bill, it'll be just kind of less, or it'll say you're plus under or something like that? Or?
That's the retailer, so we would be billing you.
Oh, so you do, okay.
Yeah. The role we're trying to play.
You can maybe pretend like there's no more paper because you just go to Etherscan to see your bill.
In Texas, when you move into a home, you get a bunch of letters in the mail, and they ask you which retailer and provider you want to choose. And like Green Mountain Energy will be like, choose us because we are X amount of wind, and they give all this marketing trying to convince you to use them.
It's actually kind of cool. They're required to publish their like average kilowatt hour prices for people. So we're hoping that we're close to the top of that list.
Choose us because we're crypto.
Choose us, we're less expensive. I don't know.
Low price is good marketing.
I know some ESCOs usually give an option for like a green program, and they just buy renewable energy credits and stuff. You guys also have an option like that.
I don't think day one, but if you saw on our roadmap with peer-to-peer energy trading, like if you're producing in your home, like with solar, you are producing green energy, and we'll be able to like map that out and offer that. But day one, I would say no.
Maybe one more?
Sure, one more question.
Anyone? Unless we
No.
exhausted. Okay.
So you're saying that here we have a robust infrastructure that's kind of underwritten by the power companies.
Mm-hmm.
So in the long run, in your worlds, who would be maintaining the infrastructure, investing in it, repairing it when there's a storm?
We still pay for that, right? The wholesale cost includes transmission, distribution, and generation. So they're still going to do that because they're making profits off it.
Right.
I imagine they're going to continue to play that role.
Cool. Mike?
All right, thank you. Thank you.
A lot of tabs.
Yeah, too many tabs. I get so much stuff to read.
Why?